Hi Elena, hope things are going well for your cousin and that you can enjoy the event. So blessings to you and yours. We're talking about mean and standard deviation of a binomial random variable today. And if you had 5 kids, and what would you expect that the number of O would be if 25% of is the number that is the proportion that you expect of your family? Well, you would take the proportion, 25, that's the chance of having O in any birth. So if you took 0.25 times 5, what does that number? Is it 1.25? All right. If you knew no statistics at all, wouldn't you expect that to be the answer? So that is the expected value between 1 and 2 children. You expect 1 or 2, basically. That's the expected value. So the expected value, we always come up with parts of a child, parts of a car. We're used to it. We're statisticians. So the expected value, 5 children, O is 25% expected in each birth. So it doesn't take a lot to understand that. So that, remember, we call the mean the expected value, don't we? So guess what the formula is for the expected mean of a binomial random variable? It is this number times this number. That's the n and that's the p. I'll switch them up because they usually put the n first. So that's the formula for the expected value. If you know you have a binomial random variable, you will find the mean of it by doing the number of trials or children or whatever times the probability of success. You may. All right. The standard deviation comes up next. I don't have an easy way to teach that to you. It would probably take me half an hour to do it mathematically. So I'm going to give it to you. And if you're very interested in where it comes from, you can read on page 391. They will explain it step by step. But let's just go with this formula. It is the square root. Are you surprised? No. Okay. No surprise there. There's always seems to be a square root involved when you see standard deviation. N times p, so it looks similar to the expected value of this binomial random variable, and then 1 minus p. And again, I don't have time to tell you why. It is understandable. So if you want to read it on page 391, they clear it up for you. All right. So let's look at the example on our page here, where we've done this actually, where there was bottled water. Remember all those bottled waters sitting here? Well, they were cups of water like this, and one was bottle, how did I do that? 1 was bottle and 2 were tap. That's what we're talking about this time. So, could you read that for us, Bailey, where it says Mr. Bullard's?
Mr. Bullard's AP Statistics class. The activity on page 340.
That's the one.
There are 21 students in the class.
All right, let me take some notes. 21 students. Go ahead.
There are 21 students in the class. If we assume that the students in his class cannot tell tap water from bottled water, then each one is basically guessing with a 1/3 chance of being correct.
All right, I'll put probability of success. Probability of success is 1/3 because there's 2 taps, tap, bottled. So there's a group of 3 and they tasted all 3 and they had to tell which was bottled. And they have if they're just guessing, they have no skill in this area at all, they will get it right by a probability of 1 out of 3, because that's how many are bottled, 1 out of 3. Okay, keep going.
Let x equal the number of students who correctly identified a cup containing the different type of water.
The bottled, okay. All right, now part A. Explain why x is a binomial. So that's over to you, Allie. You do the B. Does it pass? They're telling us it does. So explain, does it pass? Explain how it does.
It has either you think you guess correctly or you guess wrong.
Right, so it's binary. So are they independent, Brandon? Does one guess affect the next person's guess?
No.
No, so they are independent. Is this number set, Julia?
Yes.
Yeah, there's 21 guesses or kids. And Bailey, is it the same probability, if they have no skills, is there the same probability of guessing the right one?
If they have no skills.
Yeah, if they have no skills. Yes. Okay, so assuming that, it is a binary situation. So from that then, let's see if we can agree with them or not. All right. This is my homework. Hold on. All right. With that, I would like you to find the mean. We just taught you how to find the mean of a random variable. Could you take this situation and find the mean? So do that all by your lonesome. The mean of this binary random variable. I put a B for binary. The mean
What
of
do
the
the N and the
binary.
P stand for?
I'm sorry?
What do
N?
the N and the P stand for?
The N is the number of trials for children or whatever we're having, number of repetitions, and P is the probability of success. So, Julia, since you're thinking this through, what would the N be in this situation?
21.
And what would be the P?
1/3.
And what is 21 times 1/3?
7.
Good. So that's the expected value. If we had these 21 students, unskilled, it's hard to find, but we're going to find them. 21 unskilled students in this area, just pure guessing on this water event, we would expect 7. The mean is the expected value, 7. All right, what about the standard deviation of this? So, Bailey, you tell me what numbers will go under the square root from what we learned earlier.
We're going to do 7 because that's N times P.
All right.
And then you do times 2/3 because that's 1 minus 1/3.
All right, so she combined the N times the P already, because we did that above. That's the 7, and 1 minus P. P is 1/3, so 1 minus 1/3 is 2/3. So Bailey, would you tap that out for us?
2.17.
2.17. All right, we'll finish this area by remembering our skill from yesterday. And we are going to find, would you read C for me, Allie? What does it ask us to find?
Of the 21 students in the class, 13 made correct identifications. Are you convinced that Mr. Poulard's students can tell bottled water from tap water?
All right, are you surprised? Or are you just whatever? So does it make sense? It's what you expected. All right, so are we surprised? We were expecting 7 and they got 13. So let's find the probability of x being what, greater than or equal to 13. So this is a binomial. It's not chart A. It's that new stuff we learned yesterday. So we're going to find the binomial. We're going to use the function in our calculator where it said binom. Remember where that button was?
Second bars.
Second bars. Go over to second bars. You have your calculator, Brandon?
Yes.
Okay, so second bars, and we went all the way down to something. 0, was it?
Yes.
Some of us
Depends
were
on what
0.
calculator is.
Okay. So go to second bars, binom. The only thing is a little,
198.
it's going to be a little off if you did what we did yesterday. Julia, did you get what she got? Because this, we didn't do this yesterday. Yesterday this said equals. So you're going to have to go down your list one more, and it says, it used to say P, D, F, and now it's going to say C. So when it's not an equal sign, but we're looking for an interval like this, you're gonna have to do binom CDF. So what's that number? B on yours, Allie, right?
A.
A on yours? B on yours? Or is it
Mine's B.
Yeah, so it's A on everyone else's. So the binom, so you're gonna go down one more from yesterday, and you're gonna put in, what was it, N? Was that N the first thing? The number of trials, then the probability, and then the value that we're interested in. So the number of trials was 21, the probability was 1/3, and X is 13. So did that change, Julia, your answer?
What?
Did that change your answer?
It's not letting me do that.
It's not?
No, it's telling me I can't do that.
Wonder, anyone get a success?
I got a success.
Let me see what's on your screen, I'm not sure I'll know.
Well, I went to this, like you said,
Yeah,
and I don't know what's.
just clear whatever that is, yeah. No, and clear that, whatever. Oh,
But I
point.
typed in 21 and then
Okay.
I freaked out, but now it's.
All right. 0.99, Julia, what are you reading? 0.99 what?
0.9982.
All right, we're still not right. All right,
What was the right answer?
okay. The thing, I know what we did wrong. You know how this is telling you, it always, just like on chart A, this is telling you the probabilities of everything less than 13, 13 or less. But do we really want 13 or
No, we
less?
want more than that.
What, less than 13, so we find the above, so put 12.
Right, all right, so do you see what she's saying? She said it so fast. We are going to have to change this because the chart the probability function, just like the chart on the normal curve, will only tell us what's below. So,
0.9932.
0.9938?
0.9938.
4.
They're still not getting.
9984.
Oh, 0.99, did someone say 3.2? I got 0.9.
3.2.
Yeah, that's what I got.
I got
Okay.
0.9984.
Alright.
We have to do it with 12 methods.
Because we want 12
I
down,
got
not 13
0.9938.
down.
Right, the probability we really want is greater than or equal to 13, but remember the calculator is only going to give us below. So if what would equal greater than or equal to 13, the balance of that would be 12, below 12. But that will give us, Julia, you put in a 12 here instead of a 13, right? And you got 0.99. 32, and then what do we have to do with that? Because the calculator's giving us below, and we want
minus
above. 1 minus that.
0.0068.
0.0068. Is it really that low? Is it really that low?
If they have no scale,
Okay, well, so we're saying then that is 0.68%, very low. So the probability of that happening just by chance is 0.68. So is that going to happen just by chance? It is not. So therefore they do have skill. You see that? 13 out of those 21 got it right. What's the chance of that happening if it was just by guessing? Only 68%. So
Wait,
therefore,
0.68%.
they are skilled.
0.68%.
0.6.
Yeah.
That's
Point-
a big
That's
difference.
Did I say
That's a big
68%? 0.68%.
It's almost
Yeah, so it's almost 1%, getting
a little bit
close.
less than 2, a bit more than 2.
All right,
Good on.
Are you convinced?
so we learned a new thing today, and this is, sometimes we use C, the C binomial choice, and sometimes we use the B. P. So when it's P, there's an equal sign in the probability you're interested in. When it's C, we're looking for a greater than or less than sign. So you must pick up the difference. All right, let's try another one. I'll give you a little quiz, okay? I need a piece of paper, which I don't have.
You can use the homework.
The homework.
Do you have to rip it up or not? You can just use your homework.
We'll just take a quiz on this. I'll split it up. Is there any scissors over there? Yeah. All right, when you get your little quiz paper, number from 1 to 10.